Hello students, Mrs. Flavia Manje here. In this video, we are going to do a recap how to map an ERD into the logical database design. So this is our ERD here, which we are going to map and generate tables that are going to be in our logical database design. So we'll begin with supplier. It's an entity type here and it has one attribute, supplier number. So in our table, we shall also have supplier number. And it is going to be the primary key for this table. Supplier has a relationship with video. Supplier supplies video, and it's a one-to-many type of relationship, but let us first do video. Video has catalog number, and it is a primary key for this table. But like we said, it is a one-to-many type of relationship in between supplier and video. So supplier is on the one side of the relationship and video is on the many side of the relationship, meaning that supplier is the parent and video is the child. So supplier number comes to the video table and it's going to be a foreign key. So table number 3 is going to be director. Director has one attribute, director number. And it is the primary key. And in between director and video, there is a one-to-many type of relationship. Director is on the one side and video is on the many side. So that means video is our child receiving director number as a foreign key. So we will continue with our table number 4. We have actor here. There is a relationship between video and actor. So let's first do our actor table. Actor has actor number and it is the primary key for this table. And video features an actor. It is a one-to-many type of relationship. Video is on the one side and actor is on the many side, meaning that actor is the child receiving catalog number as foreign key. So we'll go to video order. There is a relationship between video and video order. So let's do our video order table. Video order, it has order number. Order number, and it is the primary key for this table. And in between video and video order is a many-to-many type of relationship. So if it is a many-to-many, we cannot identify which one is the child or which one is the parent. So in order to create a relationship in between these two tables, we will have to create a third table called comprising. And it is going to take on the primary keys of the parent table, that is the primary key of video, which is catalog number. Catalog number, and it's going to be part of the primary key, but itself alone is the foreign key. And then we'll also have order number. Order number as part of the primary key, but itself alone is a foreign key to link us back to the parent table video order. So the combination of catalog number and order number is the primary key for this table, and that is what we call a composite primary key, one that is made up of more than one attribute. So that is the comprising table. So we'll go back to video and see how it relates with video for rent. So we have a new table there, video for rent. having video number as the only attribute, and it is the primary key. So in between video and video for rent is a one-to-many type of relationship, and video for rent is on the many side, meaning that it is the child. That means it's going to take on catalog number as a foreign key. So let's go to video for rent and branch. Let's begin with the video order and branch. So we have branch as our new table. And it has branch number, which is the primary key. But it also has another attribute, telephone. Telephone as its other attribute. So in between video order and branch is a one-to-many type of relationship, and branch is the parent, video order is the child in this relationship, meaning that branch number is going to go to video order and it's going to be a foreign key. So the branch number is going to be a foreign key in this table. So that is done, video order and branch. So we'll go to video for rent and branch. We have already done video for rent and we have already done the branch table. We need to map this relationship. We need to create, to show how these two tables are going to be related. So branch is on the one side of the relationship and video for rent is on the many side of the relation. This is the one-to-many type of relationship, meaning that branch number is also going to be taken up by video for rent. So go to video for rent and include branch number, which is actually meaningful because if there is a video that has been taken for rent, we need to know which branch it belongs to. So we'll close that. Now we will go to our next table. We have rental agreement here, so let's do rental agreement, and in brackets we'll put the rental agreement attributes. We have one attribute there, rental number, and it is the primary key. So in between video for rent and rental agreement is a one-to-many type of relationship, and rental agreement is the child. Video for rent is the parent. So we'll go to rental agreement and put in video number to be a foreign key. And we still have another relationship in between. So let's first finish branch and staff. We have already done our branch table. So let's do staff. So staff has staff number as a primary key. And there is a relationship in between branch and staff. There are actually two distinct relationships. The first relationship is has, branch has staff. Staff is on the many side of the relationship. That means it becomes the child taking on branch number as a foreign key. So this table shows us that if there is a staff, we need to know which particular branch they will belong to. The other relationship in between branch and staff is the managers relationship. Staff manages branch. It is a one-to-one type of relationship, but with optional participation on one side and mandatory participation on the other. And in this case, we are supposed to identify the parent and the child, and the entity type with optional participation becomes the parent. The entity type with mandatory participation becomes the child. In this relationship, a staff manages 0 to 1 branch, meaning that not all staff members are managers of branches. So clearly staff is the entity type with optional participation, and it becomes the parent posting its primary key into branch. So go to branch and add in staff number as a foreign key. Branch has mandatory participation here because as long as there is a branch, it's supposed to be managed by a staff member. So that is why that is how we did that. We'll go to staff. Still there is a recursive relationship here. A staff supervises staff. It is a recursive one-to-many type of relationship. And what are we supposed to do in this case? We are supposed to create one table with its primary key and then add in that primary key the second time to represent that relationship. But we can't call that, we cannot put staff number as it is again in this table. That will be duplication. We'll just call this other attribute still the same, but with a slightly different name. So we'll have staff supervisor number. It is the same as staff number. The only difference is that we have included just this supervisor word here to make it different from staff number. But since it already exists as a primary key here, when it exists again, it will be a foreign key. I explained more about this in my logical database design slides, which I called logical database design summarized. So in case you want to read more about it, you can go there and read about mapping different types of recursive relationships. There is detailed explanation there. So we will go to member. There is a relationship in between member and rental agreement, and it is a one-to-one type of relationship. But let's first put in the attributes of member. We have member number, and it is a primary key in this table. Member number, member here has optional participation in this relationship. A member requests for 0 to 1 rental agreement, and a rental agreement is requested for by one and only one member. So the entity type with optional participation, which is member, becomes the parent, and that means member posts its primary key into rental agreement. So here we will have member number, and it is going to be a foreign key in that table. So let's see. We need to find out whether we have done everything. Have we finished everything? Not yet. There is another table that we haven't yet done. Let me reduce the spacing in between these tables and create some space down here. There is a ternary relationship here called registers. If it is a ternary relationship, we are supposed to first of all create the tables for the parent entity types in that relationship, which we have already done. We have the table staff, we have the table branch, and we have the table member. But after that, we are supposed to create a table for the relationship, which we are going to call registering or registration. And it is going to take on all the primary keys of the parent entity types, in this case, branch number, which is going to be part of the primary key, but also individually work as a foreign key, staff number, which is also going to be part of a primary key, but individually act as a foreign key, and member, member number, which is also going to be part of the primary key for this table, but alone it's going to be a foreign key to link us back to the member table. And this relationship registers has its attributes, date and time. So we'll still include those attributes in the registration table to show which staff registered which member at a particular branch and on which date and time. So close that table. This table has a composite primary key comprising of 3 attributes: branch number, staff number, and member number. So we will have to go back and find out whether we have done all the tables. We'll go back here and see we began with supply. Have we closed all our tables? If yes, have we put in the primary keys well? Do all tables have primary keys? The foreign keys, have they been represented very well? And if everything is correct, if everything is fine, that means we have concluded mapping this ERD into the logical database design. So in case you have any questions, please send me email. Otherwise, this video is done.